Now, in order to quantitate matter, we need to take measurements. So let's talk about the measurements of matter. And, we really have two different styles of units, I suppose, if you will. We're really interested in, SI units. And SI really has to deal with this international system of units, or it's really this French aspect of the system international of units. So we tend to look at these SI units. That's what we're really interested as scientists. However, there are or there is a different version which, I would call more, the American version. But we tend to be in our SI unit. So just to kind of break that down, we can look at, we can look at SI units, we can compare that to American type style units, but keep in mind that what we're really interested in and going forward is the understanding of SI units. But since there are two conventions, we need to be able to, kind of go between both of them. So mass would be a great way to quantify style of matter, right? Basically how much it weighs. In terms of SI units, we look to the gram or grams. In terms of American, we tend to use pounds or lbs. So it's kind of a distinction between the two. There are 454.5 grams within a pound, so there's a way to go between those two different units. But as scientists, we go with the SI. Another mode of measurement could be length. And so the meter is the SI unit, or little m. And then we could use maybe inches or even feet as our American version of that meter. We also have volume, and for volume, the actual SI unit is a decimeter cubed. Which is equal to, we're not there yet in terms of this lecture, but that's technically what the SI unit for volume is. Technically. But we don't tend to use the decimeter cubed idea with a lot of the chemistry that we look at. We tend to look at the liter, or capital L, And you can compare that maybe to the gallon in terms of the American version. We can also describe matter in terms of temperature. And with temperature, we actually have two. In terms of SI, we have degrees Celsius. And we have Kelvin. And in terms of the American, that's related to then the notion of degrees Fahrenheit. So there's our temperature. We find with the SI units, sometimes we look at degrees Celsius in terms of, a lot of times with like boiling point and melting point type ideas. When we get into thermodynamics and looking at, heats of energy and spontaneity of reactions, we'll be getting into Kelvin as the unit. One thing we can at least both agree upon is time. In terms of both, we're in terms of seconds as far as that goes. And to be honest, time just does vary as far as hours and minutes, but at least we're all on the same page as far as that goes. We have some other notions, such as pressure. Again, this is one where a unit that we don't tend to use a lot within chemistry is a Pascal. Which is basically equal to a Newton per meter cubed. I'm sorry, I said cubed, meter squared. Which is a force over an area. And so that's really our kind of definition of pressure. In terms of what we tend to use, we tend to use atmospheres in terms of pressure, and we also tend to use millimeters of mercury. So we tend to use that for our SI. In terms of pressure in English or American, it can be all over the place. But one is pounds per square inch. So there's pressure. Last one that we might have is this idea of energy. And for our energy idea, we're really looking at the notion of joules. In terms of that idea of joule or energy right, is equal to force times distance. And the units that we have for our Joule is, well, first off, we have the letter J, capital J, to symbolize joules. And these are actually in terms of kilogram meter squared per second squared, as far as the unit is concerned. There is no real American version of that idea of energy. And the last bit would be, looking at maybe force. And with force, you're basically looking at the idea of a Newton, or capital N. Newton is in terms of kilogram meters per second squared. Again, there is no American version of that. And so the idea of a Newton, or this idea of force, is equal to, mass times acceleration. So those are just some of the units that we will be getting into. We won't necessarily be getting into all of them with the same veracity, but those are some of the different units that we'll be getting into, as far as, SI units, and then also the, American version, I guess you could say. But really, at this point, just trying to go between different styles of units is going to be the important piece to this particular section.